Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core Regents exam for January 2018. These are going to be the solutions to parts 2 through 4 of this examination. These are the open-ended response questions that requires your expertise and mathematical knowledge of Algebra 2 to get these questions correct. Before we begin, do not under any circumstances cheat off of this video. I know that it's a lot of work, but you got to put in the work to get some sort of, I don't know, good grade on the Regents exam. That would be helpful, right? To help you graduate and just look good on college applications, you know, because I'm just as an FYI, colleges do look at Regents exam scores. I'm convinced I personally got into my college with my Regents exam scores. But of course there were other factors as well, but they do look at them. So don't listen to the, common misconception that, oh, they don't look at Regents scores. Well, they do. So make sure that you do well. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate the financial support to continue making these videos. It costs a lot of money to make these things. Honestly, I'm recording this as of 2018 in April, and I just laid out another $140 to pay for the software that I use. So I'm sorry to be shoving it down your throat, but it does cost money, and I do pay out of pocket to actually produce these things for your needs, because I do care about everyone in New York City. I want everyone to do well. And make sure that you visit my website at www.nysmathregentsprep.com for more math content in Algebra 2 and your future mathematical subjects. So, well, actually, one more thing before we begin here. I use the TI Inspire CX calculator heavily for this course, as you can tell from my previous videos. The link is found on my website as well. Links you right to Amazon or the Texas Instruments page. Without further ado, let's begin these part 2 questions. Now, really quick, these are part 2 questions. The 3s and 4s we'll get to, but part 2s should take it shouldn't take very long. You should get these through and get through them very quickly. So let's go ahead and try our best to, well, not try our best. I'm going to answer these questions correctly for you. But make sure that you try the problems by yourself first, and let's go through them somewhat slowly, because I need to explain everything too. 25 says, Elizabeth tried to find the product of 2 plus 4i and 3 minus I, and her work is shown below. Great. Fine. Identify the error in the process shown and determine the correct product of 2 plus 4i and 3 minus I. So you have to be a smart test taker here. It specifically says to determine the correct product. So your answer should not be, nope, she's correct. Everything's correct. Otherwise, they wouldn't have asked you the question. So let's go through these slowly. What I actually did myself is I said, all right, let me distribute this myself, and let's see where she went wrong. So 2 times 3 is 6. 2 minus I, 2 times negative I is negative 2I. 4i times 3 is positive 12i, and 4i times a negative I is negative 4i squared. Now, I squared we know is just negative 1. So this is really 6 plus 10i minus 4 times a negative 1. Oh, I already spotted her mistake. Look at this, peoples. She made I squared to be positive 1. It should be negative 1. So that's the error. So the correct product is actually 6 plus 10i plus 4, which is just 10 plus 10i. Folks, all of your answers when you're dealing with powers of I should be in a plus bi form. It's just a general standard notation of mathematical writing. So make sure that it's in a plus bi form. So identify the error in the process shown and determine the correct product. So you're going to say as shown. Elizabeth indicated that I squared is equal to positive 1. That is an ugly 1. That's a little bit better. This is incorrect. This is incorrect, as I squared is actually negative 1. The correct product is 10i plus 10. And that is all you need to do for that question. Again, it's an easy 2-point question. Be smart about it. Moving on to number 26. A runner is using a 9-week training app to prepare for a fun run. The table below represents the amount of the program completed, A, and the distance covered in a session, D, in miles. Based on these data, write an exponential regression equation, rounding everything to the nearest thousandth to model the distance the runner is able to complete in a session as she continues through the 9-week program. So, all we do is go to your graphing calculator and type into a list in spreadsheets what we need. So, we have A and D. So, we have 4/9, 5/9, 6/9. This is a new thing that they're doing. They're like skipping things around. You have to be careful. You have to go to 8/9, and this is just 1. All right, and D is 2.25, 3, and 3.25. Sweet. So now just go to Control Doc, add a calculator page, menu, statistics, stat calculations. We're doing an exponential regression equation. So your X list is A, your Y list is D, and we have all of this stuff. I keep forgetting to do this, but once again, for those of you who have headphones, turn me off for a second. It's going to be very loud and your ears are going to bleed with this sound. I had to take a picture. Here we go. There it is. So, what you should do is on your practice Regents or your printout or your book or whatever you're working with, what you should be doing is copying only a selected portion of your calculator screen. So you should be copying down the title, the regression equation, the A, and the B value. So you should be copying those 4 things down. It'll be most appropriate. Now, it says here, oops, it says to round everything to the nearest thousandth. So, rounding to the nearest thousandth, your A value, when you round it to the nearest thousandth, is 1.223. The nearest thousandth is 3 decimal places to the right. And this over here is 2.652. Now, we need to write this in terms of A and D. I'm not sure. I did not look this up. I'm not sure if you wrote X and Y, you got full credit. I assume that you wouldn't because they specifically said like A and D several times. So this is D is equal to 1.223 times 2.652 raised to the A power, because that is technically X. So this, ladies and gentlemen, is actually your correct answer. D is equal to 1.223 times 2.652 raised to the A power. All right, that's how you do that question. Moving on to number 27. By far, gonna be honest, by far the stupidest part 2 question I've ever seen in my life. And it's not because it's hard, I just think it's stupid. A formula for work problems involving 2 people is shown below. So time 1 is the time taken by the first person to complete the job. Time 2 is the second person to complete the job. And TB is the time for both of them to work together. Fred and Barney, the 2 random names. Fred and Barney are carpenters, no offense if your name is Fred or Barney, who build the same model desk. It takes Fred 8 hours to build the desk, while it only takes Barney 6 hours. Write an equation that can be used to find the time it would take both carpenters working together to build a desk. I kid you not. I was shocked that this was a question. But again, it is a part 2, but I didn't think it was going to be this easy. It takes Fred 8 hours to build. It takes Barney 6 hours. Let time, I don't know, you could do anything you want, really. Let time 1 equal Fred, and let time 2 equal Barney. Literally, all you're doing is you are taking the Fred and Barney hours, which are 8 and 6, and you're plugging it in for T1 and T2, and you leave TB alone. So your answer is 1/8 plus 1/6 equals 1 over TB. What a freaking joke that was. That's your answer, folks. Not a bad question, certainly. There is a second part to this question, and what do you think it's going to ask you for? Of course, it's going to ask you to solve for TB. Determine how long to the nearest tenth of an hour it will take for Fred and Barney to complete the job if they were working together. So this is 1/8 plus 1/6 is equal to, I can never say that, 1 over, I'm just gonna call it x. So we need to solve for x, but we need a least common denominator. My least common denominator, just by looking at it, is going to be 24x. So I'm going to multiply the top and the bottom on this fraction by, let's see, 3x, both the top and the bottom. This I'm going to multiply by 4x on both the top and the bottom. And this I'm going to multiply the top and the bottom by 24. So we get 3x over 24x plus 4x over 24x is equal to 24 over 24x. When you have the same least common denominator, get rid of them. You're setting the top equal to each other and solving for x. So we get 3x plus 4x is 7x is equal to 24. Divide by 7 on both sides, and you get x is equal to, when you do 24 divided by 7, that is equal to 3.4. So your answer is 3.4 hours. That is the total amount of time that they will take to complete the desk. Moving on to number 28. Completely factor the following expression. Honestly, I thought that this was a somewhat of a mean question. It was a mean question because you had to reorder this into a form that you're most comfortable with using. Just by looking at it, if it's 4 terms, it's probably going to be group factoring. It is group factoring, I will tell you that. But the problem is you cannot group factor these and pull out a GCF. Especially, you can pull out a GCF in the first one. You can pull out an X. But in the second one, you have to pull out a GCF. There is nothing. So we got nothing. So we have to actually rearrange these. When you rearrange it into a form that you like, this is just going to be 3x to the third plus x squared plus 3xy plus y. Yep, that's how you have to do it. You're going to group factor this. Take out a GCF over here. You could take out an x squared. You're left with 3x plus 1. Over here, you're going to take out a positive y. So we have a plus y, and you're left with 3x plus 1. Don't forget about that plus 1. When you take out a y, it's not 0 anymore. It's not going to be 0. It's going to be 1. Now, that's good. Your goal when you group factor is these things have to be the same. And if they're not the same, you did something wrong. So now we're going to combine these into a binomial and just write the yellow one once. So x squared plus y, so you have x squared plus y times 3x plus 1. Ladies and gentlemen, that is the answer to that question. Moving on to number 29. Researchers in a local area found that the population of rabbits with an initial population of 20 grew continuously at the rate of 5% per month. The fox population had an initial value of 30 and grew continuously at the rate of 3% per month. Find to the nearest tenth of a month how long it takes for these populations to be equal. Okay, cool. So I'm going to set up a rabbits equation. Rabbits, we have A is equal to PE raised to the RT. Because I will tell you right now, it is continuously. When you hear the word continuously, you want to think of PERT. Like compounded continuously, but this is just grew continuously. So it's the PERT formula. Well, what is the rabbit equation? Well, the rabbit equation is going to be A is equal to, P is the initial amount. Well, how many rabbits were initially put into the population? Well, it was 20. It was an initial population of 20. So your P is 20. E remains the same. Your rate is 5%. You have to express that as a decimal. So it's 0.05 T. We're trying to find out how long it takes. So that's time. We're finding time. Now your fox, on the other hand, it's still A equals PE raised to the RT. A is equal to the principal amount. Well, the principal amount that was initial value of foxes was 30. 30E, and the rate was 3%. So it's 0.03 T. So we have our equations. We're good with that so far. Now what we got to do, very easy, is I said that A equals this, but A also equals this. Set them equal to each other, and we're good to go. So this is 20e to the 0.05t is equal to 30e to the 0.03t. Great, let's go ahead and solve for t. Well, we're going to be using logarithms, people. That's for sure. So, the first things first that I would like to do is actually somehow reduce this a little bit, I'm going to divide each side by 30. The 30s cancel. 20 divided by 30, that's just going to be 2/3 e to the 0.05t. And that equals e to the 0.03t. Now let's go ahead and solve for t. Let's go ahead and bring this t down. Bring that t down. So we get 2/3 times 0.05t. And I'm going to leave a little blank space there just for a second. And this is equal to 0.03t. Now, when you bring down an exponent to the front with a variable in it, again and again, these are just, I say this every time, you have to write the word log or natural logarithm. In this case, I would use natural logarithm again because the natural log of e is the number 1. See this recurring pattern? The Regents likes to do this a lot. I think this is the 3rd time in the exam that they're using this property. So the natural log of e is 1. All right, great. Get rid of these. They're not technically gone. We're just multiplying by the number 1. So, okay, cool. So far, so good. Would that be the most appropriate thing to do? Yeah. So what I'm going to do is I'm going to do this very carefully. I'm going to take 2/3 and I'm going to multiply it to 0.05. We get 0.03 repeating. So you have 0.03 repeating t is equal to 0.03 t. Now, I'm going to do a very daring move. I am going to subtract the 0.03 t on both sides. Now, careful. I am going to write this as 0.03 repeating t minus 0.03 t. I am actually now going to pull out a t. Wait. If I pull out a t, that's going to make this 0. And we know it can't be 0 months. Shoot. So that actually can't work, ladies and gentlemen. We can't do that. How about this? So that actually can't work. We're still going to be using natural logarithms, but we need to manipulate this a little bit more. How about we do this? Because I knew that was going to be 0 if I did it. Oh, wait a minute. Let's go ahead and divide these. E to the 0.05t. Look at this. I'm gonna condense this just a little bit more. Look at that. If I divide those, I could subtract those exponents over there. So I get 2/3 equals e to the negative 0.02t. That's better. That's a little bit better. Move it down. Still take the natural log of both sides. So the natural log of 2/3 is equal to negative 0.02t natural log of e. That still reduces to the number 1. Ooh, divide by negative 0.02. Divide by negative 0.02. Let's try that. T is equal to, let's go ahead and type that into our calculator, control division. The natural logarithm of 2/3 divided by negative 0.02. 20.27, which is 20.3 months. So T is equal to 20.3. That was a nasty question. I'm not going to lie. Sorry for the confusion before, but I was going through it. I'm like, that doesn't look right. Well, it didn't because I was going to get 0 as an answer. But your answer is 20.3. Good. Moving on to number 30. Consider the function h of x is equal to negative 2 sine of 3x plus 1 and the function q represented in the table below. Determine which function has a smaller minimum value for the domain from negative 2 to 2. Justify your answer. Now, I am a mathematical geek. I read blogs about Regents exams, and if you've ever heard of a man by the name of Patrick Honer, I believe that's how you pronounce his last name, I love reading his posts. He rips the Regents exams a new one. I mean, he's a AP Calculus teacher, and I took AP Calculus, and, you know, as a math major, you got to go through that stuff, right? But he was spot on with one of these questions. I'm actually going to put the link in the description below as to why this question is botched, but they didn't do anything anyway. So forget that. If you're not interested, completely forget what I just said. So 30 says, consider the function h of x is equal to 2 sine of 3x plus 1 and the function q represented in the table below. Determine which function has a smaller minimum. I just said that. We have to think of minimum values as in y values. So, as listed here, the minimum value that I see is at x equals -2, the y minimum is -8. So the next thing that you should do is graph h of x equals 2 sine of 3x plus 1. So go ahead and graph this. So we have 2, the sine of, if I type that in, 2 sine of 3x plus 1. The minimum value, let's see if I do menu, analyze graph minimum. Now it's a sine graph, so I mean, it doesn't matter where you click, they're all the same minimum value. The minimum is -1. So clearly your answer is going to be q of x has the smaller minimum. So determine which function has the smaller minimum and justify your answer. Well, all you're going to say is q of x has a smaller minimum value on the domain from -2 to 2. The minimum value for q of x is -8 when x is equal to -2. And that's about it. You could say that h of x, on the other hand, has a minimum of -1. So q of x has the smaller minimum. You could say that if you want to. Okay, and that is how you answer that question. Moving on to number 31. The zeros of a quartic polynomial function h are -1, positive and -2, and 3. Sketch a graph of y equals h of k on the grid below. It says sketch, so you don't need to go crazy about it. But basically, they're asking you to take the graph that they provided, if I could get the mouse, take the graph that they provided, draw yourself some x and y axes, and sketch appropriately. Okay. So, your zeros are at -1, positive and -2, like that, and 3. Great. All you need to do is just sketch the polynomial. So it could look something like this. Done. Now, I just don't understand why they would have you sketch it. I mean, yes, it is a pain in the you-know-what to graph this function, because I actually went and graphed it accurately, but I looked at the answer key. They just said sketch. You know, they just want you to see if you could pinpoint the zeros and get the end behavior. It has to have the same end behavior because it's a quartic. It's an even function, so it has to be either both pointing upwards or pointing downwards. If you pointed downwards, that's fine too. All right, and that's how you answer that question. And you could label this as h of x equals y. Make sure that you label that. Number 32, explain why 81 to the 3/4 power equals 27. They put this a lot on the Regents exams. So, basically, you're dissecting each part. The 3 is your power. 4 is your root. You know how to write a radical in the form of the radicand raised to the power with the root over here. So basically you're saying that this can be rewritten as the 4th root of 81 raised to the 3rd power, and that equals 27. So you need to put that in words, though. It says explain. So your explanation is going to be rewrite 81 to the 3/4 power in radical form, which is what I just did up above for you, where 4 is the root, otherwise known as the index. You could write either or, it doesn't matter to me. 81 is the radicand, and 3 is the power. So you're going to first evaluate the fourth root of 81, which is 3. Then evaluate 3 to the third, which is 27. And that's how you explain it. I honestly don't know what they're going for, but that's how I would explain it. Moving on to number 33. Given f of x, this one's somewhat of a pain in the neck. Given f of x is equal to 2x squared plus x minus 3 and g of x equal to x minus 1, express f of x times g of x minus f of x plus g of x as a polynomial in standard form. So standard form means descending power order. So you are going to first multiply these two polynomials. Now, especially when it gets to like a trinomial and a binomial, you know, I'm sorry, I like to go with the box method that you learned back in Algebra 1. Just to make sure that I don't mess up. So I'm going to go ahead and do that now. So we have 2x squared plus x minus 3. And we have x minus 1. So we multiply these out. I'm going to do this very quickly. If you lost me, just go back and see how I got it. But you should have no problem with these things. It's just one of those things. All right, so I just got that. So I'm going to simplify this a little bit more. This gives us 2x to the third minus x squared minus 4x plus 3. I'm going to put these in a bracket, just so I know where I am in the problem. Now, we are subtracting the addition of these two polynomials. So it's 2x plus x minus 3 plus x minus 1. I'm just going to do it in my head. 2x squared is by itself, so that's good. X plus x is 2x, and negative 3 plus a negative 1 is a negative 4. We're almost done. Now we need to distribute that negative 1 inside. So we have 2x to the third minus x squared minus 4x plus 3 minus 2x squared minus 2x plus a 4. Combine like terms, so the 2x to the third is just by itself. So that's 2x to the third. Minus x squared minus 2x squared, that's going to be a minus, I should write that in different color, minus 3x squared. I see a negative 4x and a negative 2x. That's going to be a negative 6x. And a 3 and a 4, that gives us a 7. So your answer is going to be 2x to the third minus 3x squared minus 6x plus 7 is your answer to that question. Moving on to number 34. Probability. One of my least favorite topics, but I'm starting to get a little more confident with it. I mean, I was always confident with probability. I was just I never liked it. 34 says a student is chosen at random from the student body at a given high school. The probability that the student selects math as a favorite subject is 1/4. The probability that the student chosen is a junior is 1/16 out of 459. If the probability that the student selected is a junior, or that the student chooses math as the favorite subject is 47 over 108, what is the exact probability that the student selected is a junior whose favorite subject is math? I don't know why I had such a problem reading that. This is a tongue twister. So what you need to know is this. The probability. Suppose that, all right, so suppose that the event A is math as a favorite subject, right? We all could agree that math is the best one, right? Math is the favorite subject. So that's event A. The event B is the fact that the student chosen is a junior. So when you're dealing with exact probability, but you're dealing with, where's the word that I'm looking for? Okay. What is the exact probability that the student selected is a junior whose favorite subject is math? This is an example of or probability. Okay, this is an example of or probability. And I am currently, as of April of 2018, I am currently in the process of updating the Algebra 2 faction method code for the Regents exam. I need to start writing or typing out these formulas on there. When you have or probability, or in other words, if you're trying to find a student selected is a junior who happens to like math, you probably have not learned set notation because they took it out of the Algebra 1 curriculum a while ago, but it's called the union of something. So this is, you're finding the probability of A union B, okay? So it's the probability of A union with the probability of B. Now that formula is the probability of A plus the probability of B minus the probability of A intersection B. Okay, so that U means union and the upside down U means intersection. So what is the probability of A union B? Well, if the probability that the student selected is a junior or that the student chooses math as a favorite subject is 47 over 108, well, that is P of A union B. Well, that's just going to be 47 over 108. So the probability of A, well, what's the probability of selecting math as your favorite subject? Well, that's just 1/4. The probability of being a junior is 1/16 over 459, and we're actually trying to solve for the probability of A intersection B, because that's what we're going for, people. The student selected is a junior whose favorite subject happens to be math. Well, that is the intersection of the two events. Let me try to phrase it a little bit differently because I keep saying these words. You might not be grasping onto the concept. The probability of A union B is, in fact, the joining of the student selected as a junior or that the student chooses math as a favorite subject. The intersection is, okay, what's the probability that the student is definitely a junior and that student likes math? That's what we're going for, and that's just another way to phrase the statement. The student selected is a junior whose favorite subject happens to be mathematics. So we're trying to solve for this. I am not going to do the calculations that much, so just type this into your calculator. You get 47 over 108 is equal to 923 over 1836 minus the probability of A intersection B. When you solve for this, you are going to subtract this, and you're going to move it to the left-hand side of the equal sign. When you do that, you get the probability of A intersection B, or the negative probability of A intersection B, is negative 31 over 459. Divide by that negative 1, you get the probability of A intersection B is equal to positive 31 over 459. Ladies and gentlemen, that is the answer to that part of the question. Now, there's a follow-up. Are the events, the student is a junior and the student's favorite subject is math, independent of each other? Explain your answers. So you need to know the test for independence. This is another formula that I'm going to add on my review packet. The test for independence is the probability of A intersection B does equal the probability of A times the probability of B. Now, what's nice about the previous part of the question is that they wanted you to find the probability of A intersection B. And that's what you need to use for the test for independence. There are other ways to do the test for independence, but this is probably the most straightforward way. So we know that the probability of A intersection B is 31 over 459. That is going to equal the probability of A, which is 1/4, times the probability of B, which is 1/16 out of 459. When you multiply these together, we get 31 over 459. That does not equal, and when you type this into your calculator, you get 29 over 459. So if they're not equal to each other, they are not independent of each other. If they were equal, then they are independent. So, therefore, that means therefore this is not independent. And it just says, explain your answer. Okay, fine. Because the test for independence fails. That's it. Done. That's it. That is an ugly box. Independence fails. That's better. Okay, that's your answer to that question. Moving on to a statistics question. In a random sample of 250 men in the United States aged 21 or older, 139 are married. The graph below simulated samples 250 men, 200 times, assuming that 139 of the men are married. Fine. Based on the simulation, create an interval in which the middle 95% of the number of married men may fall. Round your answer to the nearest integer. So, I'm sorry. This question has appeared, I want to say, on every single Algebra 2 Regents exam. You should know by now that the middle 95% is the mean, plus or minus 2 standard deviations. That's important stuff. Now, they tell you that the mean is this. They tell you that the standard deviation is this. Let's go in and do it. So the mean plus 2 standard deviations. We're going to evaluate that and the mean minus 2 standard deviations. Let's go ahead and evaluate those numbers. So this is going to be the mean, which is 138.905, they tell us, plus 2 times the standard deviation of 7.950. This is going to be 138.905 minus 2 times the standard deviation of 7.950. When you enter those into the calculator, I'm not going to do it. That's 155. It's 155. It says round your answer to the nearest integer. This is going to be 123. So your interval, ladies and gentlemen, is going to be 123 to 150. That's an ugly 5. 123 to 155. There you go. That's your interval. Done. Moving on to part B. A study claims that 50% of men 21 or older in the United States are married. Do your results from part A contradict this claim? Explain. So they're saying 50% of men of 21 or older are married. So, what do we know here? In a random sample of 250 men in the United States aged 21 or older, 139 of them are married. Ladies and gentlemen, 139 out of 250 people. That is 0.556. That is about 55, it's about 56%. Okay, fine. So, what does that tell us anyway? You know, you just type in that number. What does that tell us? Well, a study claims that 50% of the men 21 and older in the United States are married. Do they agree with these statistics here? Well, the interval is from 123, somewhere over here, to 155, somewhere over here. It says here, 50% of men 21 or older are married. Well, yeah. Ladies and gentlemen, that is a huge chunk of people. That is a lot of people who are married, who are 21 or older. So, do they contradict? I don't know why they do this. Do they contradict the claim? No. Do they support the claim? Yes, they do. But for this answer, does it contradict the claim? No, it does not. It supports the claim. So, you're going to say no. I know that's annoying. No. My results do in fact support the claim. Because numbers that are greater than or equal to 125 within the interval of 123 to 155, or in this case, we could rewrite this as 123 is less than or equal to x, which is less than or equal to 155, indicates that 50%, sorry, it just indicates 50%, not that 50%, but it indicates 50%. The interval of 125 to 155 shows 50% or more of men 21 and older are married. Now, what in the world does that mean? I gotta explain this because I can't just leave it as that and move on. So, what I'm saying here is that from the interval from 123 to 155, that indicates 50%. We know this because I just said that 123 to 155 is the middle 95%. That's fine so far. But the interval of 125 to 155, which we know it is, where is that number? 125, I lost it. 21 or older. Yeah, okay, so, okay. 50%, I'm sorry. 50% of 250 men is 125 men. Well, 125 men lies inside the 95% confidence level of 123 to 155. So that's why it does, in fact, support the claim. And that's basically what I just said in this statement. Moving on to the last part 3 of this exam, then moving on to the part 4s. The graph of y equals f of x is shown below. The function has a leading coefficient of 1. That's good to know. Write the equation of f of x. So, I swear, do not get confused with this. The root is x is equal to 3. The root over here is x equals 0. The root over here is x is equal to negative 4. What are the factors, folks? Well, the factors are the opposite of the roots. So the factor is x plus 4. The factor is x minus 3. And the factor of this, well, if x equals 0, then your factor is just x. But is it? Let's see. Write the equation of f of x. Well, f of x is going to be x plus 4 times x minus 3. I have a question for you. I only see 3 x's there. Isn't that a cubic function? Isn't that a quartic function? Because a quartic has the same end behavior, and it has 4 roots. Would be a pretty good idea to download that fact sheet muscle code for the Regents exam, right? Do not forget, please don't forget the word multiplicity. Oh my god, it's coming up frequently on these exams now. Multiplicity is it's the characteristic of the root shown on the graph. It is the relationship between the characteristics shown on the graph and the amount of times the root repeats itself. So, believe it or not, that is a bounce. It bounces off the x-axis, so this is technically x squared. So that's why I withheld that information from you. So this is x squared. Ladies and gentlemen, that is the equation of f of x. Now, if you decided to distribute and you wrote down f of x is equal to x to the 4th plus 3x to the 3rd minus 12x squared, that is also perfectly acceptable. All right, moving on to the second part. The function g is formed by translating the function f left by 2 units. Write an equation for g of x. I kid you not, I found this so funny. When I was doing the answer key, on the day the exam came out, I was doing the answer key, and I'm like, oh my god, I couldn't figure this out. I kid you not, for 20 minutes. Couldn't figure it out. I'm like, well, I was looking at this stuff. I'm like, well, if I were to put it into this form, like I was trying to translate it, I'm like, but this isn't a quadratic, it's a quartic. I'm so stupid, right, people? I'm so dumb. All you have to do is literally take this function and move it over 2 units to the left on the graph. That's it. Move it 2 units to the left, and you're good to go. So your graph is going to look something like this. Something like that. Now, when you move it 2 units to the left, that's just going to be g of x is going to be x plus, this is, all right, so now this is x is equal to negative 6. This is x is equal to negative 2. And this is x is equal to positive 2. So you're, no, I'm sorry. That's a 1, not a 2. That's going to be x is equal to positive 1. So your function, g of x, is going to be x plus 6. This is going to be x minus 2 quantity squared. And this is just going to be x minus 1. Ladies and gentlemen, that is your g of x. Done. Nice. Moving on to the final question of this examination. So, the resting blood pressure of an adult patient may be modeled by the function P below, where P of t is the pressure in millimeters of mercury after time t in seconds. Great. On the set of axes below, graph y equals P of t over the domain from 0 to 2. So, great. They put that there, so there's going to be 2 over here. Okay, cool. I'm going to go ahead and graph this on my TI-inspired calculator. So you have 24 cosine of 3 pi t Nope, sorry, X. Ignore that I just typed in PI. It's so much faster for me when you're typing it on the computer. But it does give you pi, I promise you. So, I am going to change my window. I know that the amplitude is 24, and I know it's a vertical shift of 120 units up. So your amplitude, I'm actually going to go from like 90-ish to 120 plus 24, that's 144. I'm going to go up to 150. So menu, graph entry, no, sorry, window zoom, window settings. I'm going to go from 0 to 2, like they said for the X's. I'm going to make that 1. The minimum value of Y is going to be 90, and the maximum value is going to be 150. And I'm going to count by tens. There's my function. Great. Great, great, great. So let's go ahead and graph this. Label appropriately. So this is going to be 90. I'm going to count by 5s here. So this is 95, 100, 105, 110, 115, 120, 125, 130, 135, 140, and this is 150 up here. So I am going to leave you to copy down the table of values for Control T, and you're just going to basically... Oh, that's horrible. Oh, okay. So basically what you're going to do is you are just going to use your menu, analyze graph, minimum, and you're just going to click here, before and after, and you're just going to click the maximum, and you're just going to do it a couple times. You can't use the table of values. It's just annoying. You're just going to do it a couple times to get your X values, because we know the Y value. It's going to be 96 down here and 144 all the way up here. You just got to get your X values. But it looks like it's going by a third each time. You're adding by a third. So that's fine. I'm going to go ahead and graph this to the best of my ability. This is going to be 144. Great. So it's going to be right here. I'm going to go down. So I'm actually counting by 2 boxes. So this is going to be, what is that, 96. Great. Count by 2. Go back up. Count by 2. Go back down. Count by 2. Go back up. Count by 2. Go back down. And back up again. I'm going to try the very best to sketch this appropriately. Oh my god, that's already bad. Okay. Jesus, this is hard. I can do this better with a pen and paper. Okay. I think that's decent. Okay. So I'm going to label this P of t is equal to 24 cosine of 3 pi t plus 120. And that will give you, I think it will give you about like 2 points on that question, maybe 3. There's a follow-up question. It says determine the period of P, explain what the value represents in the given context. So you should know by now that the period of a function is just 2 pi over b, where b is a frequency. Well, remember what frequency means. Frequency is how many times the curve repeats itself in 2 pi radians. Well, we don't even need to know that because the frequency is given right here. Because remember that the cosine curve is given as y is equal to a cosine b of x, in this case plus d. I'm not going to include the plus c somewhere because that's a horizontal shift. There is no horizontal shift going on here. So this is the general equation of the cosine curve. So the period is actually 3 pi. No, I'm sorry, not the period. The frequency is 3 pi. So the period is going to be 2 pi divided by 3 pi, which is just 2/3. Ladies and gentlemen, that is the period of this trigonometric function. But what does it mean? Let's figure it out. So the period. Well, the period, and it's talking about the resting blood pressure of an adult patient. Well, the amplitude is the blood pressure range. It's going from 96 to 142. The period, on the other hand, represents the oscillation, the movement of up and down between the maximum and the minimum blood pressure levels in 2/3 seconds. That's what the period is. So the period is the amount of seconds that this is oscillating back and forth. So we're going to write that down. So the period. The period represents the oscillation between the maximum and minimum blood pressure levels in 2/3 seconds. And that is the answer to that part of the question. Good. Final part. This is nice. This makes us feel real healthy. Normal resting blood pressure for an adult is 120/80. Honestly, I don't even know what my blood pressure is. I should know because I'm getting older. This means that the blood pressure oscillates between a maximum of 120 and a minimum of 80. Adults with high blood pressure, which is above 140 over 90, and adults with low blood pressure below 90/60 may be at risk for health disorders. Classify the given patient's blood pressure as low, normal, or high, and explain your reasoning. Well, the maximums are 144. The minimums are 96. That is certainly above 140 and above 90. So this patient does have high blood pressure. So, they certainly need to cut off. What causes high blood pressure? Salt, sugar, stress levels. That definitely. Oh boy, especially during Regents time, right? So your answer is actually going to be high because the maximum blood pressure reading is 144. That's just from the given diagram that I showed you before. And the minimum blood pressure reading is, that looks like a C. The minimum blood pressure reading is 96. So both of these readings are in fact above the normal range. And that, ladies and gentlemen, is how you answer that part of the question. And that is the end of this Regents exam. Cool. Make sure that you hit that subscribe button down below. I hope that this helped you. Consider becoming a patron on my Patreon page and visit my website at www.nysmathregentsprep.com for more math content in Algebra 2. And I hope to see you soon.